Welcome to solverfy.
Okay, so we're doing chapter 23, problem 21 here. So it says the volume charge density rho e within a sphere of radius r naught is distributed by rho e as a function of r is rho naught r or 1 minus r over r naught squared. So this is our function for rho e, and where r is measured from the center of the sphere and rho naught is a constant. Okay. For a point P inside the sphere, so that means R less than R naught, determine the electric potential V, and V at infinity equals 0. Okay, so we first need to find the electric field. Since the charge distribution is spherically symmetric, we know we can use Gauss's law, where E dot dA is just E times the surface area of a sphere, and this equals the charge enclosed over epsilon naught. So the charge enclosed is now given as 4/3 pi r cubed times rho e of r all over epsilon naught, the total volume, 4/3 pi r naught cubed. Okay. But this is actually not the case, actually. We can't just take the ratio of the volumes here times the volume density because it's not constant. If it was constant, we could do that, but now it depends on r. So actually, we have to take another step here. So we need to calculate what charge enclosed is, and this is given when we don't have a constant rho e of an integral. So we want to integrate from 0 to r rho e of a function of r dv. Okay, so let's do that. So charge enclosed is integral from 0 to r. If we change dv to dr, we're left with 4 pi r prime squared, and now we have rho naught 1 minus r prime squared over r naught squared dr. Okay, so let's solve this. We have 4 pi rho naught, and now we have r squared on the first becomes r cubed over 3, and then we subtract off r to the fourth, so this is r fifth, r to the 5 over 5 r naught squared. So this is what our charge enclosed is. So let's take this back into our Gauss's law equation, and we should see that E is now 1 over 4 pi epsilon naught over r squared times 4 pi rho naught r cubed over 3 minus r to the 5th over 5 r naught squared. So let's cancel out these 4 pi's, and some of these r's are going to cancel out, and we're left with the answer of our E field being rho naught over epsilon naught, and we have r over 3 minus r cubed over 5 r naught squared. Cool. So that's our E. Another thing we need to find out is what the total charge is, which is the same as integrating what we had before from 0 all the way to r naught. If we do that, we see something very similar to this equation, but it all simplifies out to being 8 pi rho naught r naught cubed all over 15. Okay, we're almost there. We almost have what we need. We know E for inside the sphere. We know what Q enclosed inside the sphere as a function of R is, and we know the total. So now if we're trying to figure out the potential at R, we can subtract off the potential at R naught, and see that this is the same as the negative integral of E dot dl from R naught to R. Okay, so why don't we do this integral? So this becomes the negative integral from R naught to R of rho naught over epsilon naught R over 3 minus R cubed over 5 R naught squared dr. And let's calculate that. And this becomes negative rho naught over epsilon naught. We have R squared over 6 minus R to the 4th over 20 R naught squared. And this is evaluated from R naught to R. Okay, so let's add a page here. If we're trying to solve for VR, which is V as a function of R less than R naught, this is now V naught plus the answer we have down there. We haven't evaluated it yet, but we just add V naught over. So this is V at R equals R naught plus our answer from before. So VR, let's figure out what V naught is. Well, V naught is just the potential from a point charge with the total charge. So this is Q total over 4 pi epsilon naught R naught. Sorry, this is V naught. So if we plug in what we got for Q total, we can simplify things more. And this comes out to being 2 rho naught R naught squared over 15 epsilon naught. Okay. Lastly, we plug in our stuff. There's a V naught, and we add on our answer. All evaluated from R naught to R. So now we can just plug this in. Let's pull out our rho naught over epsilon naught. We should see we're left with R naught squared over 4 minus R squared over 6 plus R to the 4th over 20 R naught cubed. And this equals V of R less than R naught. Finally, we got there. Lots of integrals, but we made it.